This video is going to look at area and circumference of circles. So here we have a circle and the composition of a circle. So the circumference is what we refer to as the outside, or in other words, the perimeter of the circle. The area is this little shaded bit in the middle. Now, there's certain words we come across, and you will be familiar with these from junior cycle. The radius is essentially half of the diameter, with the diameter being the full breadth or length of the circle. The centre obviously is the blue dot here. Now, it's not always referred to as the centre C. It can be given any other letter. In this video, we're going to be reintroduced to this symbol, which we all know is the symbol for pi. And pi is always 3.14, or as a fraction, 22/7. And we'll use pi when we're calculating the area and the circumference of a circle. If we're asked to leave in terms of pi, that just means we leave pi in our answer. Let's have a look at this example. So we have two formulas. We have the area of a circle. It's usually written as pi r squared, or you can put the multiply symbol in, and the circumference of a circle, 2 pi r. Now, both of these are in your formula and tables book, so again, it's not a case of learning them off, it's a case of learning how to use them. So let's take the first one, part 1. We're asked to find the area and circumference of a circle where the radius is 15 centimetres, and for part 1, they want it in terms of pi. So we've got area, and it's pi r squared. And it's in terms of pi, so it's going to be pi in our answer, times 15 squared. So it's going to be 225 pi centimetres squared. And the circumference is, the formula is 2 by pi by r. Well, again, it's in terms of pi, so it's 2 times pi times 15. 2 times 15 is 30. So it's 30 pi centimetres. And that's part 1. Let's have a look now at part 2. So we're told we're going to fill in and take pi to be 3.14. Well, in that case, area is pi r squared. Pi is 3.14 times r squared, which is 15. So what we're going to be left with is 706.5 centimetres squared. And then the circumference is 2 by pi by r. Pi is 3.14 and r is still 15, and that leaves us with 94.2 centimetres. Now let's do it where it's 22/7. So looking at part 3 now, the difference is we're taking that pi in this question is 22/7. So area, very simply, is pi r squared. So what we're going to say is 22/7 times 15 squared. And when we put that into our calculators, we're going to come out with 707 and 1/7 centimetres squared, or you could put it as a decimal, is fine too. Now let's have a look at the circumference. So I'm just going to move these across a little bit. Circumference is 2 times pi times r. So it's 2 times, sorry now that's a funny looking x, 2 times 22/7 times r, which is 15. And when we put that into our calculator, we're going to come out with 94 and 2/7 centimetres. And you can put that again as a decimal if you wish, or you could leave it with the fraction. Okay, so looking at part 4 now, they want us to use the pi function on our calculator. So on a Casio calculator, the pi function is actually down here, okay? And you're going to have to use your shift function to get to it. And the little symbol for pi will appear up here beside your formulas. So practice that and see can you use the pi function. Now what I want you to do is practice your use of the area of a circle formula and the circumference of a circle formula. And try find the area and circumference of these circles. So you've got a radius in this one, a radius in this one, and a diameter in this one. And you're going to have to think back to the start of the video where I told you what the relationship between the radius and the diameter is. And question 2 is a little bit like a context and applications question that you would see in the papers. So you're given an abstract statement such as a satellite orbits the planet and it travels at a radius of 3,000 kilometers, and that's shown in the diagram here. And then you're told that the satellite orbits the planet at a height of 100 kilometers and a speed of 6,000 minutes per second. How long to the nearest minute does it take the satellite to complete a full orbit? So what you're thinking of there, if this is a satellite and it completes a full orbit, what are we thinking of? How many minutes does it take to go around the circumference? So see how you get on with that question. Give it your best shot.